Welcome to this video which demonstrates the principle of the falling cat flywheel. The falling cat flywheel is equivalent to a standard rotating flywheel but does not have any joints that undergo complete revolution. This property is what allows the falling cat flywheel to be implemented with flexures. The application of this falling cat flywheel is to substitute the reaction wheel for the control of satellite orientation. The mechanism consists in two pivoting inertias and has a single degree of freedom. The kinematic chain consists in two constant velocity joints and one ball joint in the middle. The constant velocity joint at the top is formed with two flexible blades in the horizontal plane and a vertical flexible beam. The ball joint at the bottom consists in three flexible rods. To show that this flywheel can be used as a reaction wheel, it is motorized with a stepper motor which makes the flywheel turn with the help of a crank. To show that this mechanism is able to export torque and store angular momentum like a standard reaction wheel, the flywheel and its motorization are placed in a frame that is able to rotate. This means that when the motor is turned on, the rotating frame is set into motion. The residual rotation that can be seen once the motor is stopped is not a fault of the flywheel, but of the experimental setup. Indeed, there is friction in the ball bearings of the rotating frame, and therefore angular momentum is lost. This means that the system is not perfectly isolated. Nevertheless, this experimental setup shows that the falling cat flywheel is able to serve as a reaction wheel for spacecraft attitude control.